Good morning, children. Welcome to your chemistry online class. Last class we discussed about the structure of functional group in alcohol, phenol and ethers. And in today's class we are going to discuss about a very important topic, that is the preparation of alcohols. How can we prepare alcohols? In haloalkenes, haloarenes, we have seen that we can prepare alcohols. From haloalkanes, we can prepare alcohols by different reactions. So how can we prepare alcohols? Can prepare alcohols by mainly by three methods, that is from alkenes and from carbonyl compounds and from grignardates. So let's see one by one. So from alkenes we can prepare alcohols by acid catalyzed hydration. So what is acid catalyzed hydration? Here acid is the catalyst and this is a hydration reaction. What do you mean by hydration? Hydration is the addition of water. So here we can see alkenes react with water in the presence of acid as catalyst to form alcohols. In case of unsymmetrical alkenes, similar to our haloalkenes and haloarenes, it will follow Markovnikov rule. So what do you mean by Markovnikov rule? In Markovnikov rule, we know that the substituent which is attached to the least numbered carbon which having least number of hydrogen atom. So here the substituent is alcohol. So alcohol will attach to the carbon which having least number of substituents, least number of hydrogen atom. So here we can see the hydration reaction. So here you can see alkene is reactive with the water. Water is an unsymmetrical molecule. It is one side is H, the another side is OH. So it is an unsymmetrical compound. So here we can see what will happen is in the addition reaction, this unsaturated bond will change to one carbon, oxygen will substituted, another carbon, hydrogen will added. You can see some more examples. In the case of symmetrical carbon, no problem, any product we can form. But in the case of unsymmetrical carbon, what will happen? Unsymmetrical alkene, we know one side there are two carbon, this side but one carbon. So it is unsymmetrical. So according to Markovnikov rule, what will happen? So the OH will added to this carbon atom because it is having only one hydrogen. Hydrogen will added to this carbon because it is having two hydrogens. You can see the mechanism. The first step is the protonation. Before the protonation, the water molecule will is acid catalyzed. So acids are the compound which have the ability to donate H plus. So the water and as a hydrogen will form H3O plus, and this H3O plus will attack the alkene. The first step will occur, that is protonation. That is, here we are adding the alkene, the H3O plus molecule, attack of H3O plus molecule. So if the H3O plus molecule attack the alkene, what will happen? So there is the formation of carbocation by electrophilic attack because it is an electrophile, and there is a formation of carbocation. And the second step is nucleophilic attack of water on carbocation. Second step is, this is a nucleophile. So first step is electrophilic attack, second step is nucleophilic attack. So if the nucleophile attach to the carbon, what will happen? It will substitute here. Then deprotonation to form an alcohol, that is removal of H plus, that is a deprotonation. Hydrogen is also known as a proton. It is having only one plus charge, so it is also known as protons. So protonation, deprotonation, that is removal of plus charge, that is removal of hydrogen will occur here, and we can see then we will get our alcohol. Then another method of synthesis of alcohols are addition to carbonyl compounds. What are carbonyl compounds? Carbonyl compounds which contain C double bond O bond. Can you give any examples? Those are aldehydes, ketones, carboxylic acid esters, Those are carbonyl compounds, and the carboxyl group behaves very much like carbon-carbon double bond. So similar to the alkene, it's contain a double bond. Similar to that, we can easily break this bond under several conditions. So if we add H2, so here is the addition of hydrogen, so it is a hydrogenation reaction. So what will happen in the addition of hydrogen? This bond will break, that we can see. So the addition of hydrogen is also known as reduction reaction. So here you can see we are adding hydrogen to aldehyde, it will yield primary alcohol. If we are adding hydrogen to, that is we are conducting hydrogenation in ketones, it will form secondary alcohol, that we can see. But in this reaction we need some catalyst, that is our D block elements. Here you can see the addition on aldehyde. So here you can see one hydrogen is added here and one hydrogen added to the O group, then we are yielding primary alcohol which having only 2 carbon atom, that is instead of this carbon atom one more carbon atom attached to this. Secondary means there are 3 carbon atom. In tertiary there are 4 carbon atom. The 3 carbon substituents attached to the carbon which having hydroxyl group. Here 2 groups are attached, that's why the secondary. Here 1 group attached to the carbon which having hydroxyl group, that is why it's primary. So here we can see it yields primary compound, and here we can see it is secondary, and here we can see in the case of carboxylic acids and esters, from carboxylic acid and esters we can form primary alcohols in the presence of lithium aluminum hydride, because it is very good reducing agent, is very strong reducing agent. But there are several steps for this reaction. If we take a carboxylic acid, this functional group is COOH. So if we reduce COOH, it will first form aldehyde, then form alcohol. The first step is it will form aldehyde, then only it will give alcohol. But in the presence of strong reagent like lithium aluminum hydride, the strong reducing agent, so what will happen is, in the first step itself it will yield alcohol, from carboxylic acid to directly alcohol. So commercially acids are reduced to alcohol by converting them to the esters. Then first commercially how we can produce alcohol means, from first acid will convert into esters. From esters we are doing catalytic hydrogenation. Catalytic hydrogenation means in the presence of catalyst we are doing addition of hydrogen. Here you can see the examples. Here you can see the preparation of alcohol from carboxylic acid. So lithium aluminum hydride and H2O we are using. So we are getting primary alcohol. And the second type, the commercial purpose, for commercial purpose we are using, first this is our carboxylic acid, we are adding alcohol to this. This is known as esterification reaction. It is the reaction between carboxylic acid and alcohol. If a carboxylic acid and alcohol reacts together, it will form an ester. This is the ester form. It is RC double bond OR dash, and we are conducting the hydrogenation in the presence of catalyst. Then we will get alcohol. We are getting 2 types of alcohol, that is primary alcohol and methyl alcohol. So we learned how to prepare alcohols from 2 methods, from carbonyl compounds and from alkenes. Then we'll move to the next type, that is from Grignard reagents. So what do you mean by Grignard reagent? It is CH3MgBr, that is there is a direct metal carbon bond They are organometallic compounds. From that we can easily prepare alcohols. So we are producing alcohols from aldehydes and ketones using Grignard reagent. So the first step is the nucleophilic addition of Grignard reagent to the carbonyl compound. Then there is a formation of adduct. Adduct is we can see that. Then hydrolysis of the adduct. So it's contained mainly 3 steps. First is nucleophilic addition, then adduct formation, then hydrolysis of the adduct. Here you can see this is the carbonyl compound, that is from alcohol and phenol we are making our from aldehyde and ketone we are making our alcohol. So here we can see the Grignard reagent. We know in the Grignard reagent magnesium having positive charge and alkyl group having negative charge. First step, the alkyl group react attached to the carbon, so the bond will shift. So there is a negative charge creation on the oxygen. So there our magnesium will attach. So there is a formation of adduct. So adduct, it is unstable. So if we are adding water to this, there is hydrolysis of this adduct occurring. So this, what will happen? This Mg, here we can see the hydrogen will attach to here. From this MgX to the MgX, the OH group will, from the water, we know it is HOH, it is unsymmetrical. So the hydrogen will attach here and OH will attach here. This is the reaction. So then we can see several compounds used from Grignard reagent. We can make several type of alcohols, primary, secondary, tertiary. 3 types of alcohols we can form from Grignard reagent. I hope all of you understood this. We can see which type of aldehyde we are using. Like that we will get the product. From formaldehyde, this formaldehyde. Formaldehyde will get primary alcohol, and we can form secondary alcohol. And from, if we are using ketone, we will get tertiary alcohol. So I hope all of you understood this topic. So thank you.